All right. So welcome everyone. So I see there's a few people coming in still. So I guess I'll start right away, and people can join as we go. Yeah. So hi, my name is Patrick Zetane. I'm the CTO of Zetane Systems, and with me there's Mina Amiri. She's a senior data scientist, and she'll be presenting after me. So this is how it will go. So I'll present, and after that, Mina will present. And then after this, we'll take questions. So if you have questions, you can write them in the chat. There's yeah, so I can see all your questions, so I can go, and if I look during while my try to answer them as I go. So I promise I'll do my best. And yeah, so today we'll look at new visual techniques to assess and optimize and debug data sets and machine learning models used in industry. And here, what we're really focusing on is what is happening in enterprise and in industry. We're not really focused on the academic side, although it's really important, but we'll be sharing some of our experience, and we'll be talking about tools we developed to actually solve some of those issues. And so, yeah, let's see. Okay, so Zetane's a company. It's based in Montreal, and we basically do software and AI services. We're a team of software developers, data scientists, people with experience in high performance computing, simulation, and 3D rendering. And you'll see all these skills all come up really well together, especially when you'll see the tools we developed. We're really about robust and transparent AI, and our objective is to get more AI project approved and deployed in enterprise. And we have noticed that it's quite a challenge all over the industry, and we'll be talking about this today. So just to know a little bit more about us, we have multiple clients, um, basically in the realm of construction, defense, medical, aviation, safety, and so on. And yeah,
Hi, Patrick.
yes.
I'm just letting you know, I don't know if you're supposed to slides now, but they're not appearing.
Oh, that's a good point. Okay, sorry about that. I think I got it there.
Sorry to
Okay.
interrupt everybody. Okay,
No, no,
thank
that's
you.
good. We didn't miss much, but I'll go back. All right. Okay. So yeah, so that was the title. And that's us. And this is the team. Like I said, based in Montreal, but it's a very diverse team, a really great team. And like I said, it's all about getting AI projects approved and deployed in enterprise. And these are some of our clients in construction, defense, medical field, aviation safety, and so on. And what we know is that it's really important. Those are all high risk applications of AI. So it becomes really important to be able to test and validate everything about your AI models. And some of our great partners been supporting us a lot. So that's thank you so much to all these partners. And so yeah, so I'll give a little overview. I'll talk quickly about machine learning in enterprise, and then I'll show you and tell you some of the tools we developed to address these issues. And after this, I'll present you something called a validation, testing and validation checklist, so that using the tool, you can actually go through the checklist and be able to figure out what is happening in your ML models, and what can you do to improve it, and also how can you use this to prove to the stakeholders, business stakeholders, if it's going to work when you deploy it. And after this, Mina will show us like use cases of applications of uh, using those tools to find, I'd say, pretty important optimizations and gain deeper understanding in the models. And yeah, if you want to know more about us, that's our website, zetane.com. So yeah. So we've realized, I mean, this comes from different sources. So 80 to 90% of AI projects will never make it to production. What makes it to production also is not, it's not necessarily high risk. So there's a serious issue in industry. On the one side, you have everything that great state of the art models that comes up in academia and great papers and so on, but this is really nice data. And what it turns out that in enterprise, it's not only about the data, but it's about like getting the buy-in for all the stakeholders and be able to show that your models will be working well in production. And also, like I said, it's really about the deployment risk to be able to assess this. And there's many things involved in AI projects in enterprise, so I'll be covering some of these. And so this is based on basically our experience working with companies. And so I'd say the story goes a little bit like this. There's a business opportunity, and then someone has evaluated that there's some return on investment in certain part, something that can be automated or that can gain a lot of advantage by using modern ML models. And usually there's a one or two person that are kind of the champion, and they will be carrying this project internally. They will be doing the work. They will try to connect and get everyone to get in together on that project. And like everyone said, you need data, and you need good data. I would not say it's about the quantity, but it's about getting good data and actually getting the data. So I'll be talking next slide a little bit more about this. And there's a lot of people involved. It's not just like one or two people. It's not just the data scientists. It's horizontally. There's lots of colleagues that will have to work together, but also horizontally, there's managers above. And I would say it's like a team sport, but with coaches and general managers above, that everyone wants to understand what's happening to invest in these projects. And those projects, it's not necessarily about the deployment, but it's also getting more funding to go from proof of concept to MVP and beyond. So this is every time you need money, and you need to be able to carry your project. Project needs to evolve within an enterprise. And so the data, I mean, of course, there's different types of data. Those are the kind of questions you need to ask. And it really changes all this discussion. I'd say quantity is important for sure, but I'd say also quality is extremely important. And there's certain models that if you have less quantity, it's okay, as long as it's very high quality. So there's different things that can be done. So I'd say you need a quantity and quality. When I say quantity, it's not too much; it's just the right amount. So sometimes we think you can only have a lot of data, and otherwise you can't do anything. You just need to have the right amount. And related to the data, you need to really ask questions such as, is it accessible? Or is there confidentiality issues? Who owns it? Is it a client? Is it the company you're working with, and so on? What's the type of database? And also, who will get it, and how will they get it? And who understand the data, because sometimes there's data, but there's maybe one or two people in the company that knows about all the tricks and the meaning, even the definitions of the type of data. So you need to know that you can access these domain experts. And how long will it take to get the data is also a really important question. I'd say ML projects should not start until you get the data, because then you really know what you have to work with. And before that, it's planning, I would say. And like I said, there's a lot of people involved. I mean, I started a list here, and maybe it goes from software developer, data scientists, of course, but also all the sometimes like CTO, CEO, R&D director, um, AI project manager, and so on. And sometimes it goes down to even like, I would not say down, but who owns the Excel sheet? Who has an Excel sheet with all the data? It can be multiple lines, and sometimes it's like, if it's business data, sometimes it can even live as CSV files. So these things, everyone will basically need to know about the project itself. And ultimately, for everyone, it's about understanding what AI is, how it works, and having a fair grasp of how it's processing the information. And also, I'd say it's about trusting the solution before and after it's deployed. And this becomes important because it will never get deployed if it's not trusted. If it hasn't been tested and validated and proven to the people that give the okay, you can deploy this, and I know what the risks are. And these are really they're the people that will be able to tell you, okay, I need this in that format and so on, and then I can deploy it. And so we've realized that there's a few needs, and we've extracted them. We're realizing that you really need actionable insights so that you can eliminate the guesswork. And from that point of view, it's from the data scientists working with the model. Sometimes you can go a certain direction, but there's really, even if you train and tweak and do automatic optimization of your model, it still won't be enough to achieve the performance you're seeking. So it's really about focusing on what's important in the model. Then you go to validation and testing. So the story with this is that you need to be able to analyze your ML solution, but you cannot do it only with a few performance metrics. It's not enough. You need examples. You need to be able to show what the outliers are doing and everything. Otherwise, you just have a few numbers and you don't know the texture behind those numbers. These numbers, it's their averages, their statistical analysis, and basically you need to know a little bit more about what's the actual thing happening behind. So you need to know to prove what's happening, especially for outliers. And you need to know what's the are the operational boundaries, what can you get in put in your model, and what you're expecting to come out, and that's important. And as another point, which is probably not what a data scientist usually thinks, is that you need to get the buy-in for your project to flourish and to move ahead. And sometimes it's the AI supervisor that needs to get the buy-in from other stakeholders. And so you really need to people need to understand what's happening. They need to know what the project is about and what AI is. And yeah, so I'll go to the next one. So based on that, we've developed a tool, and our tool is really meant to open the neural network and be able to inspect it, observe what's happening, and test and validate everything about the data passing through your model. So we can think about it as a new tool, like a microscope or a telescope, to actually open your neural networks and be able to look into them. And so for us, it's all about like quickly accessing the data manually or automatically, so that you can debug, optimize, test, validate. So ultimately, you can trust the model itself, and also save time, because every time you figure out something about what's happening at a certain layer in your model, then you can save days and even weeks, and maybe you'll get accuracy improvements that you could not have. Achieve without having observed something into the model. And obviously, you will save server costs, and server costs. When you pay the bill, they're not low, I would say. So that's something to think about. So for now, I mean, we have a pro versions, but we also have a free Zetane viewer. So if you want to try it, you just have to go on the website and you can download it. So you'll be able to open the models. There's a few models that you'll be able to open. So they're called ZTN files, and you can download them from the website on the gallery. But also, you will be able to open models. They're called Onyx models, and they come from multiple frameworks, and I'll tell you more about it in the next frame. So what you're able to access is look at the model architecture, open the tensors, and we support everything that can be converted to Onyx or I mean Keras also, and PyTorch model directly from the API. So all these can be seen. So if you can save it, you can load it in Zetane. So it can be a multi-layer perceptron, an LP model, as long as you're able to save it. And yeah, so Onyx, just so some people might not be familiar with Onyx. It's sorry, it's you for us. It's about opening them, and you can go download them in the Onyx Model Zoo, and it's an open neural network exchange. So you can see here all the frameworks convert to Onyx. Most operators are supported, and after this, you can perform inference through them. So can also be really useful for deploying your models. It's actually a really good framework to deploy your model with. And we're part of the consortium. there's a lot of people trying to get all frameworks to pass through at least one common standard, and it's working really well. It's the GitHub stars are going up, and yeah. So now I think I'll do a little demo of the platform. Okay, so I've loaded the viewer, and you can also go on the website to download it and try it on your own. So what you can do is go look. There's a few here. That's a few examples that you can go look at and inspect them. So we provided a few snapshots, we call them, and this way you'll be able to inspect the model. I will open another one. It's based on what Mina will be showing us. This one is a UNet for medical image segmentation, and we'll be looking at it so you can have a glimpse of what's happening in those models. So we have the original image, which is a long X-ray, and so we have it here, and it's and the ground truth is this, and the model was trained, of course, with the target, the ground truth, and this was what it predicted. So that was a state-of-the-art model. So it's doing really well here and there, but we'll see it will get much better. So what we can do here is now we have the model architecture, and you see it all. It looks like a U. So this is basically the model architecture, and each of those box or nodes, those nodes are operators, or depending on the framework, they are layers. So in this case, you're inputting this to your network, and instead of just getting the output, you're able to access everything about your model. Every tensors after the data goes from left to right, and as it passes through all the operators, the input data is changing. So now we're able to really look at all the feature maps. And in this case, this is the output of that node. So this is conv operator, and after this there's ReLU. And you see ReLU is a really nice function in a way because it really cleans up the noise, I would say, and it really keeps what's the most important. So we can see there's a few things of interest here. Maybe I'll take this one. And you might notice that there's a kind of a focus on the corners here. And I think Mina will tell us more about this, and I will leave it like that for now. So this is one view, but you can also access the tensors themselves. This is more like in raw form. So this allows you to basically, oops, sorry. So this gives you access to the shape of the tensor, like with one glimpse at it. So you're able to see the tensors, but you can also go inspect all the values of your tensor. So in this case, you'll have access to absolutely every value of the tensor, but also with one click, you're able to see the distribution of the values. And for example, if I click on the weights, you're seeing this is the weight distribution, and usually when you see this curve, that's a really good sign. So yeah, so I'm looking at the time, so I'll go a little bit more quickly so that Mina can talk really soon. And yeah, so this I already saw, so we can access all this information. And the thing with this is that there's a special workflow for this, is that you're in the software, and like you saw, I basically just loaded the model. In this case was this DM model, but I can also load the Onyx model, a Keras model, and be able to open them directly in the viewer. And then in the Viewer Pro, you can load your own input. So you could choose your input to test your model. So here I have provided an input, but you would choose your own input, and these input can be chosen the right way. And so I'll go a little bit quickly around over this, but so you saved your model from your own framework. After this, you extract some inputs directly from your Python file, whatever framework you're using. You can save some of the inputs. There's a lot of analysis you can do. And as long as you keep them, you're able to load them after and pass them through your model and expect how it's behaving. What we realize is that when you really focus on the outliers, you get so much information from looking. You actually understand what to optimize really quickly. And I would say like the top 10 inputs with lowest performance are usually the best to look at. And you should also look at some that had good performance, and it will tell you more about this. So they can compare what's a low performance input and what's a high performance input, and how do they behave through the model. And after you load it, you can get all your insights. And so now that you have a set of inputs, you can start looking at what to do with it. And I mean, you basically need to go through a checklist to see what is happening in the model. So when you're designing the network, you would look at the architecture that you don't necessarily need the input. You look at the shape and the weights initialization. This is what I showed earlier. And with the weights, you're able to know, is it been well initialized? Should I change my initialization and so on? After this, for the inputs, you can start looking if there's empty tensors. That's when I clicked on a button and there was a screen on the right. Is there, what's the value distribution in the histogram? Are there dead neurons? And Mina will tell us more about this. And also look before and after activation functions. We think it's because there's just a one click away, it's really quick to actually get access to this information. And you can also save your model while you're training and at different epochs and inspect your model based on your input set so that you can really figure out is it even learning well? Is it reacting correctly to your test input? And ultimately it can lead to early stopping of your model. And so there's a few observations that you can see and related to distribution. Sometimes there's a visual artifact and so on, and you'll discover many more things. And yeah, so now I'm looking at the time, and I think I'll just finish with that part. Um, so so one thing that's important is also for AI on the side of AI services at Zetane, we also can, using the Python Zetane API, we can build really rich dashboards, including 3D objects, images and camera images, and so on with all the data. So by using this, we're able to demonstrate to many stakeholders the value of AI, and also for the people who will be looking at the model running all day, you would need to have those dashboards. So that's another thing we do. And yeah, so at this point, I think I'll just kind of review a few of the things. So basically, we have the Zetane engine, which is beyond the free viewer. There's a Python Zetane API, so directly from your code, you can launch your model in the Zetane engine. It supports any framework. And you can load your inputs for inference. And we also have like libraries for explainable AI that are part of our Python or Python import files. And yeah, and also we really focus on robustness, model confidence, and transparency. And like I said, if you want to download it, it's here. And yeah, I think I'll let Mina go for now. I maybe talk too much, but yeah. And also, if you have questions, please feel free to write them in the chat.
Hi, everybody. Thank you, Patrick. And thank you, everybody, for joining us today. So I'm going to present some examples of what Patrick just mentioned. I start with some examples when we could use the Zetane engine during implementing a model, and then I will provide some examples when we want to inspect and investigate a trained network. So when we are designing a network, the data is really important, as you all know, in deep learning, and we need to make sure that we are feeding the correct data to the network and the shape of the data is correct and the normalization is correct. And also the architecture, regarding the architecture of the network, we want to make sure that all the layers are connected correctly. We don't have copy-paste issues by like copying some layers and forgetting to change the inputs or hyperparameters. And we want to make sure that we have all the skip connections, activation functions, batch normalization, and concatenations correctly. So before I start the examples, I go through the definition of segmentation, because most of the examples I'm going to talk about are in this application. With the segmentation, the goal is to assign a label to each individual pixel. And there are two main types of segmentation. The first one is semantic segmentation, when we don't care about different instances of the same object. And the other one is the instance segmentation, when we care about different instances. So in this case, we have two labels, one for the person or people and one for the background. And in this example, we have 6 different labels, 5 for people and 1 for the background. And to evaluate the segmentation, there are different measures. But in this presentation, I mainly focus on the DICE index, which is an index between 0 and 1. And this is the equation. So it's the intersection of the ground truth mask and segmented mask over the summation of each of these masks. And the DICE score of 0 means there is no overlap between the ground truth and segmented masks. And the DICE score of 1 means that we have the perfect segmentation and the complete overlap. So this is the first example I'm going to talk about, and Patrick mentioned a little bit about it. It's about the importance of data in AI. This is the example of some feature maps from one of the networks that we developed for segmenting the lines from the X-ray dataset. And we had very good results, but when we investigate the model, we realized that the network is paying much attention to the corner of the images, and we see a strong activation at this part. And we realized that these strong activations are due to the white tag, which was used to hide the information of the patients. So we realized that we need to clean the data before training the network. And we did that. We removed the white tag and tried to train the network again. And we could improve the DICE score from 0.97 to 0.98. We already had good results, but we could improve. And you can see that we don't see that strong activation at the corner anymore. And this is another example of medical data that we use the CT images to segment the COVID-19 lesions. And because the data was in a specific medical data format, there was a header with different types of information about the data. And at first, we didn't care about those information, and the network was seeing the data like this, which wasn't correct. And after visualization, we realized that we need to change the pre-processing and conversion before feeding the data to the network, because the network didn't see this header, but the Python libraries were seeing the header and the information. So we could see the correct data in the Python, but the network didn't see the correct data. And this is one example of the importance of normalization. You all know that each network can work with a specific type of data, with a specific range of the data. This is an ImageNet, which is used for classification. I use this input image, and I got the output as a shopping cart, which wasn't correct. And then I realized that then the data is not normalized. It's between 0 and 255. So then I normalized the data, and between -1 and 1, and I could see the correct results, which makes sense. And about the structure of the network, with Zetane, we could easily see the overall structure of the network. For example, in this case, you can see a UNet with all the skip connections from the encoder to the decoder, and all the activation functions and the U shape. And if we zoom, we can see this is, of course, another network. We can see different layers, different activation functions, batch normalizations, and all the connections between different layers. And if we even more zoom, we can see, as Patrick mentioned, we can see the feature maps, the histogram, and all the all the filters and the bias and the output of each layer. So it can be used in verifying the network architecture when we're designing a network. Usually what we do, we use a piece of paper and draw the network, or we can use TensorBoard in different frameworks. But with Zetane, we can easily see all the networks and have a confidence in designing a network. And the second part of my presentation is about when we have already trained a network and we want to validate it and maybe try to improve the performance. And this is, I think, more interesting. So again, as before, that we need to validate the data in terms of the shape, histograms, normalization, etc. And we have access to internal intensors. So we can inspect the feature maps, filters, biases, inputs and outputs. Again, the shape and histogram of each layer. And we can investigate activation functions and dead neurons. And also we can validate our network and try different data and see how network performs with different examples, and to see if we can improve the performance by like some pre-processing or post-processing or changing the network, so on. So here are some examples in this section. This is one network we trained for segmenting some medical images. And as you can see in this branch of the network, there is no signal passing, and all the feature maps are 0. So it's really hard to detect this issue by just coding or by just investigating. It would take a lot of time, but by visualization, we easily see that in these there's some issues in this branch, and we added batch normalization to each layer, and we could normalize the input data to each layer so that we had the signal passing through this branch as well. And also we could have different another type of activation functions, such as leaky ReLU instead of ReLU. And this is another example which is very similar to the previous one. We had a network to segment the satellite images, and we wanted to improve the performance of the network. What we would do would be to have a more complex model or to include more data during training. But with visualization, we realized at the beginning of the network, again, there are some layers that are not passing the signal, and we are losing the information in these layers. And we already had batch normalization, but the problem was that we had the batch normalization after the activation function. But we just moved the batch normalization before activation function, and we could improve the results from like around 2%, from 88 to 90. And this is another example when we had weak segmentation in segmenting tumors in medical ultrasound data. And we should have done some error analysis. But what we did, we looked at the histograms of the data at the last layer, and we realized that in images with good results, so we had some images with good results and some images with poor results. In images with good results, we had a steep histogram, and you can see 2 examples here. And in some images, we had a broad histogram at the end, which resulted in poor results. So based on this observation, we developed an adaptive thresholding method, and by this method, we could improve the DICE score in images with poor results. So this is one example of the ground truth. This is using the old method, and this is after applying the adaptive threshold, which you can see that we could increase the DICE score quite well. And this is the last example I'm going to present, which is really interesting to me. This is about the object detection using YOLO V5 network. We use this example just to see how the network is working. And the network was able to detect this person with a high confidence score. I think you cannot see, but it's 0.91 score. And when we looked at the internal feature maps, we realized that the network is looking at the neck area, at this area to decide whether this is a person or some other classes. And we could see this pattern in many kernels and many layers. So my hypothesis was that maybe this is the neck area which is important in detecting the person class. So I just, to test it, I divided the image into two parts, the head part and the neck and the bottom part. And as you can see, the confidence score dropped for 2.41 for the top part. And we had better results for the bottom part, which is confidence score of 0.75. And I tried another example. Again, in this case, the head wasn't detected at all, but the bottom part was detected as a person with the confidence score of 0.75, which is really interesting. And then I included the neck to this image. So I included the neck area, and now the network was able to detect the person as a person. So the lesson, of course, it's some observations and need more investigation and more research, but the lesson we can get from these examples is that we need to include more data like this with only the head area to train the network, because the network apparently hasn't learned to detect these images as persons. And we need to include, we need to improve the data set to train the network. So yeah, by visualization, then internal tensors, we can decide if we had a good data set to train the network, or we had some drawbacks and we need to change it, change the data set. And yeah, thank you very much for being with us. And I think we will have some minutes, a few minutes for questions. So I guess I stop sharing, and Patrick can also join us to have the questions. And yeah. So you can both use the chat, or you can like come on the screen and ask your questions.
Yeah. I think it's funny because now whenever I look at a model, I always think like, okay, so this model is looking at necks. That's all human are. It's like walking necks. It's really interesting. So yeah. Yeah. So I have a question here about for NLP models. The idea is to it's the same tool. So you basically just need to save your model, say, to an Onyx format, and you'll be able to load it directly in Zetane. And we're releasing also a pro version, and we'll be able to load the Keras models natively. So NLP models are just made of tensors and operators, so it's the same thing. So you'll be able to open them the same way. So it would be the same process. We show a lot of computer vision because it shows well for presentation, but then NLP model worked also. Yeah. So that was, yeah. Well, another question. Otherwise, we'll wrap up 1 minute before the end. We did it. Managed to stop myself from talking too much, Mina. So that's good. Yeah, okay. So feel free to reach out to us. Maybe also our LinkedIn if you want. You can get in touch with us for any reason. We're nice people. We'll be able to help you in any in whatever you need. So cool, great. Thank you so much.
Thank you, everyone.
Bye-bye.
Bye.